In this example, we're asked to find the gradient of the curve. Gradient is the rate of change of one variable with respect to another. And in this case, it's the rate of change of y with respect to x, which is nothing more than dy dx. So in terms of what we're asked for here, we're just asked for dy dx. Gradient is dy dx. And if we look at this function here, we've got x's and y's intermingled. It's not feasible to get y by itself. We've got a y to the fourth and we've got an xy, so we can't just get all the y's on one side and all the x's on the other. So we're going to use implicit differentiation, which we've just covered. So let's go through our template. The first thing is to find the derivative with respect to x of everything, every term. So we've got d dx of x to the fourth plus d dx of xy plus the derivative with respect to x of y to the fourth equals the derivative with respect to x of 1. So we've got to find the derivative of every term. And let's do that now. So find derivative with respect to x of x to the fourth. So that's just the derivative of x to the fourth, so that's 4x cubed. Now this one's a little bit tricky. X and y are both contain y as a function of x, so we've got a product rule going on here. So we've got, if we've got u is equal to x and v is equal to y, so we've got u v dash. Now u is equal to x, v dash, the derivative with respect to x of both sides here is just dy dx. So that's u v dash plus u dash v. U dash is equal to 1 and v is just equal to y. So 1 times y is y. So derivative with respect to x of xy is x. So that's u v dash. So that's dy dx plus u dash. U dash is 1 times y. Plus, now here we've got chain rule going on because we've got y as a function of x, so there's going to be some dy dx involved, but we've got y to the fourth. So if you like, we diff in. So the derivative in is find the derivative of y, and that'll be dy dx. And then diff out, the derivative of y to the fourth will be 4y cubed. So that's 4y cubed times dy dx, and the derivative with respect to x of 1 is 0, derivative constant. So that's our first step. We've found derivative with respect to x of all terms. The second step is to get all the dy dx's on one side and everything else on the other side. So first of all, we've got to get these two terms here together on the left. So, whoop, not that one in the middle there. That one's got to go to the other side, and that one's got to go to the other side. So we've got x dy dx plus dy dx 4y cubed equals, the y's got to go over to the other, minus y minus 4x cubed. So the third step is to factorise left hand side. So we got dy dx's can come out the front, and we're left with x plus 4y cubed equals minus y minus 4x cubed. And lastly is divide by a. So if this is a up here, we've got a there, so we're going to divide right through by that, and we get dy dx equals minus y minus 4x cubed all over x plus 4y cubed. So dy dx we said was the gradient, and we've we've calculated dy dx, so that is the gradient. We can calculate the gradient using x and y values at any point on that curve.